Toyota eCVT reliability, the 2026 Honda CR-V e-HEV transmission, 2026 Toyota Camry highway fuel economy, and the massive debate over hybrid drivetrain longevity are the only topics that truly matter to anyone looking to survive a long-distance commute for the next 15 years. But there is a brutal, engineering-backed truth about these two systems that neither dealership is willing to admit during a high-pressure sales pitch. Why is it that the two most dominant hybrid transmissions on the planet, Toyota's planetary power split device and Honda's dual-motor direct drive system, behave so differently when you're cruising at 80 miles per hour on a sun-baked highway, and which one is actually designed to reach 300,000 miles without a catastrophic five-figure mechanical failure? If you've been comparing the new 2026 RAV4 or the redesigned Accord Hybrid and wondering if the infamous rubber band sensation of the Toyota or the fixed gear philosophy of the Honda is better for your specific driving pattern, your gearhead instinct is absolutely right to be skeptical, because these are not just different brands. They are two completely opposing theories of mechanical thermodynamics and metallurgical stress. By the time you finish this technical breakdown, you will understand the precise engineering reasons why Toyota's transmission-less design is the undisputed king of low-speed durability. You will uncover the hidden damper stress reality that makes Honda's highway-friendly system a potential ticking bomb at high mileage. And you need to stay tuned until the very end, because I'm going to reveal the one specific temperature threshold buried in the transmission control logic that determines exactly when your hybrid transaxle starts its slow, inevitable walk toward the scrapyard. To understand why the Toyota eCVT versus Honda e-HEV debate is so vital in the 2026 auto market, we first have to address the biggest myth in the entire automotive world: the idea that these are normal CVTs. In a standard gasoline car, a continuously variable transmission uses a steel belt or a chain stretched between two variable pulleys. These systems are notorious for slipping, wearing out the pulley faces, and overheating during long climbs. But as a veteran gearhead who has seen the inside of more transaxles than I care to count, I'm here to tell you that neither Toyota nor Honda uses that fragile technology in their mainstream hybrids. Toyota's eCVT, found in everything from the 2026 Corolla to the Lexus high-performance SUVs, is actually a power split device. It uses a simple, robust planetary gear set, the exact same heavy-duty architecture found in the final drives of tanks and industrial drills, to blend the power from the gasoline engine and two high-output electric motor generators, called MG1 and MG2. There are no belts to slip, no friction clutches to burn out, and no complex hydraulic valve bodies to clog with sludge. From an engineering standpoint, Toyota's design is a masterclass in mechanical minimalism. Because the gears are always in mesh and never shift in the traditional sense, the only real failure points are the bearings or the varnish insulation on the copper motor windings. This is why you see Toyota Priuses in taxi fleets with 400,000 miles still running the original transmission hardware. The system is fundamentally overbuilt for the task of daily transportation. Honda's e-HEV system, featured in the 2026 Accord, Civic, and CR-V, takes a radically different electric-first approach that prioritizes driving feel over mechanical simplicity. For about 90% of your city and suburban driving, the Honda doesn't use a transmission at all. Instead, it operates as a series hybrid, where the gasoline engine runs a generator to create electricity, which the traction motor then uses to turn the wheels. However, the engineering gets complex when you hit highway speeds, typically above 45 or 50 miles per hour. At this point, the system engages a high-voltage mechanical lockup clutch to connect the engine directly to the wheels through a single fixed gear ratio. This creates a direct drive fifth gear sensation that is incredibly efficient for steady-state cruising because it avoids the energy losses associated with converting mechanical power to electricity and back again. To a driver who grew up on naturally aspirated V6 engines, the Honda feels much more normal and responsive on the highway than the Toyota. But the ugly truth that marketing brochures hide is that this lockup clutch and the associated torsional damper are the most stressed components in the entire drivetrain. Every time the system transitions from electric drive to engine drive, that clutch must engage, creating a torque shock and heat cycle that the Toyota system simply never experiences because its gears are always connected. The second brutal truth that no one is discussing on YouTube is the highway heat cycle difference between these two architectures, particularly in the 2026 auto market where speeds are higher and vehicles are heavier. In a Toyota eCVT, the electric motors are constantly spinning at high RPMs to manage the gear ratios at highway speeds. This generates significant eddy current heat inside the transaxle casing. Toyota attempts to manage this using the engine's coolant and a dedicated world standard or WS transmission fluid to keep the internal temperature stable. However, if you follow the dealership's lifetime fluid advice and never change that oil, the microscopic metal shavings that naturally wear off the planetary gears begin to act like liquid sandpaper. Over 100,000 miles, these particles wear down the protective varnish on the copper motor windings. Once that varnish fails, the high-voltage motor shorts out, and your reliable Toyota becomes a $7,000 paperweight. Generally speaking, if you ignore the manual and change that fluid every 60,000 miles, the Toyota eCVT is arguably the most durable transmission ever mass-produced. If you don't, you are gambling with the laws of physics and the dielectric strength of old oil. Honda's highway vulnerability is much more subtle, but arguably more concerning for the second and third owners who buy these cars out of warranty. The E-HEV system relies on a mechanical damper between the engine and the generator motor to smooth out the inherent vibrations of the four-cylinder internal combustion engine. In the 2026 auto market, as Honda has pushed for more torque and higher highway efficiency, these dampers are being subjected to millions of vibration cycles. Research into high-mileage E-HEV units in Europe and Asia, where these systems have been on the road longer than in North America, is starting to reveal a pattern of spring fatigue. When these internal springs lose their tension or snap, the car begins to develop a violent shudder during the transition to highway cruising. Unlike the Toyota system, where the gears are the only moving parts, the Honda has a physical clutch pack and a complex damper assembly that will wear out over time based on the number of engagement cycles. Dads across the globe are starting to realize that the smoothness of the Honda comes with a mechanical expiration date that the boring Toyota simply doesn't have.
Let's address the psychological factor of driving disconnect and how it influences used car resale value in 2026. A huge portion of the debate between these two systems comes down to how they sound under load. When you floor a Toyota RAV4 hybrid to pass a truck on a two-lane road, the engine revs to its peak efficiency RPM and stays there, creating a loud, constant drone that many drivers find unrefined. This rubber band effect is what makes people think the transmission is slipping, even though it's actually the most efficient way to accelerate. Honda has attempted to solve this with linear shift control software, which uses the electric motors to fake the sound and feel of traditional gear changes. It sounds better, it feels more premium, and it helps the 2026 Civic Hybrid feel like a driver's car. But as a veteran gearhead, I'm telling you that fake sound and simulated shifts are just more layers of software and hardware complexity. If you want a car that is a mechanical tool for the next 20 years, you want the Toyota's transparency. If you want a car that is a digital toy for a 3-year lease, you want the Honda's refinement. The global perspective on these transmissions is also revealing. In Australia and the Middle East, where highway driving often means hundreds of miles in 45 degrees Celsius heat, the Toyota eCVT remains the gold standard for fleet operators and high-mileage commuters. They know that planetary gears don't care about ambient temperature as long as the lubricating fluid is fresh and clean. The Honda E-HEV, while gaining massive popularity in urban centers, is still viewed with skepticism in these survival markets because of that lockup clutch. In a high-heat environment, any friction-based clutch experiences thermal glazing, where the friction material becomes smooth and loses its ability to grip. If that lockup clutch starts to slip on a remote highway, the car's fuel economy drops by 30% and the system throws a transmission malfunction code that requires a specialized high-voltage technician to diagnose and repair. This defined versus undefined risk is why Toyota still commands a resale premium in the 2026 used car market. The buyer knows that gears don't fail, but clutches do. We also have to discuss the towing and payload reality, which is a major concern for fathers and families. Toyota's eCVT architecture is remarkably good at handling load because the planetary gears can distribute torque between the engine and the motors without any physical parts sliding against each other. In contrast, when you tow with a Honda e-HEV, the system often has to stay in series mode, electric drive only, because the load is too high for the single fixed gear ratio of the lockup clutch to handle. This means the engine is screaming at high RPMs just to generate enough electricity to keep the motor turning under the weight of the trailer. This creates a massive thermal load on the inverter and the generator. If you are a highway warrior who frequently carries a full load of passengers or tows a small boat, the Toyota system is much more thermally robust for sustained high-load work. You have to understand that the Toyota tax isn't just for the badge on the grille, it's for the metallurgical hardness of the gears inside the case. So, how do you actually choose in the 2026 car market? It starts by being brutally honest about your daily driving pattern. If you spend 80% of your time in city traffic and your highway driving is a 20-minute blast at 60 miles per hour, the Honda e-HEV is a fantastic, smooth, and incredibly efficient choice. Its electric-first philosophy is perfect for the urban stop-and-go cycle. However, if you are a true highway commuter, someone who does 50 or 100 miles of 80-mile-per-hour cruising every day, or someone who lives in a mountainous region where the transmission is constantly working against gravity, the Toyota eCVT is the only system that offers true mechanical peace of mind. Its design is simply more thermally mature for the rigors of sustained high-speed work. I want to hear from you in the comments below, because this is where the real data lives. Do you prefer the mechanical honesty of the Toyota eCVT or the digital smoothness of the Honda e-HEV? Have you experienced the highway shudder in a high-mileage Honda, or have you reached 200,000 miles on your original Toyota transaxle fluid? Let's get a real argument going, because the truth about these drivetrains isn't found in a glossy dealership brochure. It's found in the real-world experiences of the people who actually have to pay the repair bills once the warranty is gone. We need to hold these manufacturers accountable for the long-term repairability of their high-tech transmissions, and that starts with sharing the actual data from the people who keep these cars on the road. Now, as I promised at the beginning, I'm going to reveal the one specific temperature threshold that determines the fate of your hybrid transmission. That number is 100 degrees Celsius or 212 degrees Fahrenheit. In both the Toyota and Honda systems, this is the critical viscosity cross. When your transmission fluid, whether it is Toyota's WS fluid or Honda's ATF-DW fluid, reaches 100 degrees Celsius during a high-speed highway run in the peak of summer, its ability to protect the internal bearings and gear teeth drops by nearly 50%. More importantly, this is the specific temperature where the electric motor varnish begins to experience accelerated aging. If you're the kind of driver who pushes your hybrid on the highway in July with the AC on full blast and a car full of gear, your transmission is spending its entire life at the very edge of this thermal cliff. This is the hidden expiration date of the modern hybrid.